Okay, let's start. So, in Smalltalks 2009, we had a fantastic talk by Dan Ingalls. The name was 40 Years of Fun with Computers. Everybody was very impressed, including myself. So, for this year, Valeria and I turned 10 years with working for Caesar. So I changed this 40 with 10, computers with Caesar, and the Ingalls with Leandro. I'm sorry about that. So here we have in Smalltalk 2011, 10 years of fun with Caesar by me. So Caesar, what is Caesar? Is a company that where we work on a product. The name is PetroVR. It's about the oil and gas industry. This is the name of the product, not the name of the company. But so this is for the oil and gas industry, and we define it as a simulation of the full business cycle. So the story of PetroVR started a long time ago, in 1996. There was one engineer, actually a petroleum engineer, that wrote some stuff. First, of course, in Excel, then in Actor, and finally in Smalltalk. So the productivity of Smalltalk allowed the system to grow, and the productivity of this guy also. So this small company, after some few years, was looking for professional Smalltalkers. So here is when Valeria and I came in and started to work for this company. The company is based in Houston, Texas, and we are based in Buenos Aires. So we work remotely for Caesar since November 2001. I was very young. So the system, well, was a mess. Lots of globals, of course, no documentation, no test, and no clear architecture. So it took us about 2 years, this was by 2003, that we actually started to make sense of all that Smalltalk code. And, well, by that time we have already hired some other Smalltalkers in a still small team, but we didn't understand what we were doing. So we were maintaining some system, but we didn't have any clue of the domain. What was that system about? So we hired not a programmer, but someone that could go and learn from Google, from Wikipedia, from books, from magazines, from many places, something about the domain, so he could tell us what we were doing. So we could have some kind of vision of our lives. So 1 year later, by 2004, we had a very good understanding of the direction of the product, the company, the domain, and the system. So we decided to start a secret project to rewrite the entire system from scratch. This is one advantage of working remotely. You don't have to tell the decision makers the truth. So by 1 year later, by 2005, this secret project had proven for us to be feasible, and so we presented it to the decision makers, and they approved the project, of course. So in 2006, after 2 years of very hard work with this secret rewriting of the system, the new system was released and the old one was left behind. So if you count from day one, it had taken us 5 years to reach the place where we could start fresh. So after 5 years, we said, this is a good job. In parallel, because when you rewrite a system, an existing system from scratch, you still have to maintain the old one, because the new system is only in your laboratory, it's not in production. So users who pay the bills are using the old system. So we had to maintain in parallel the old system. This is incredibly hard, but we could do that. And that effort, well, left us very exhausted, but happy. And the users, of course, resisted the new version with skepticism and obstinacy. So, but we were really happy because now we had several features that we really appreciated. Like, for instance, a full-feature simulation engine. The system was a simulation system, so we had that properly. We had a lot of tests. Now we had a development environment which we had built in the process, a very clear architecture, comprehensive documentation, programming rules and patterns. This is very important. It's not a boring thing. And frameworks and design guidelines. So we started to build not just the system, but the way we build systems. As we progressed in our development, then we discovered many other things that go beyond the development environment, like quality assurance and documentation and many other things. So help desk and the contact with the clients and the users. So many processes and workflows were emerged from this adventure. And soon, PetroVR gained a reputation as a complete, reliable, and versatile system. Versatile. So we were in a very good position to start to build serious stuff. Okay? So I will show you some of the few things, or many things actually, that we did in these years. So simulations was one chapter, another was optimization. We also had some mathematics, decision analysis, authoring, engineering, quality control, project management, interoperability, and some research. So these are the main chapters that will make sense if you try to classify all the projects that are involved in our software. So let's see some of these. And of course, all of this is Smalltalk 100%. So in the chapter of simulations, by the way, following every part of the system, I took the opportunity to refresh some presentations we have made in these years in conferences like ISAC, Smalltalk Solutions, and Smalltalks. So, for instance, we presented in the Innovation Awards in ISAC 2008 our simulation engine. And the simulation engine is a dynamic simulation engine that combines two approaches, the discrete and the continuous approach. I cannot go in detail in each of these items. There are two modes of operation. One is deterministic and the other one is probabilistic. Most of people, including myself in the past, think that simulations are essentially random or probabilistic, but it also makes sense to have deterministic simulations. And the projects that can be simulated in our system span over several decades, in some cases longer than a century. Remember that our clients are gas and oil companies working on very expensive and complex projects. So the second chapter, which is present in our software, is something around optimization. We made a couple of presentations this year, in ISAG, and there is another one in this conference on Saturday, I think. The system has a lot of graph theory because imagine that you are working for this gas and oil projects, so you have routing algorithms to send the production from the wells to the consumers. In the middle, there are many things happening, like pipelines and facilities and many other things. So graph theory has to be applied here because there are many constraints in the routing. So these algorithms are not trivial. And if you go to the books, for instance, most of the algorithms for graph theory that present constraints only deal with one fluid. But here you have several fluids because you have gas, oil, water, and these main fluids also have components. So the complexity of the graph is bigger. We also had to learn and implement simulated annealing, an interesting optimization technique that you can learn about that in Saturday. This is used to honor correlations between random variables. And we have all sorts of curve fitting, zeros, max, mean, with all the known algorithms that students at university should learn, like Box-Cox, Newton-Raphson, and all the common stuff. The system also has scheduling, which is algorithm to optimize things that happen in time, but you are not certain about when that things will actually happen and if they will happen at all. So scheduling is another source of algorithmic that we have to deal with. In mathematics, this is a very important topic for us because there are two mathematicians in the team. We have a lot of probabilities and risk analysis, so we deal with probability distribution, samplings, correlations, Monte Carlo, clustering, conversions, statistics. With the calculus as well, because we have to compute derivatives and integrals that are related to the instantaneous rate at which the fluids are flowing. And also we have to integrate to capture the cumulative production of oil, gas, etc. There is also a lot of financial mathematics because the system also solves all the problems related with the economic calculations. So we have economic and financial models applicable to all fiscal systems in the world. This is about mathematics. Another thing we had to learn was about decision analysis. This is a real topic. There are books about this. There are libraries, courses in universities, something that I didn't know before starting with this. So decision analysis is a very important topic. So the system has to support decision analysis in a very rigorous way. So we support that with sensitivity analysis, scenarios, decision trees, influence diagrams, tornado and spider plots, conditional execution, value of information. All of these are topics that are covered in the average decision analysis book that you can come to now to read. We also worked a lot on portfolio risk management. This is another chapter that has to do with this topic, efficient frontier for portfolio analysis. Efficient frontier is a way to understand the benefits against the risk. So maybe if my portfolio is like this, I have wonderful benefits, but the risk is very high. And maybe I want to resign some benefits, but with a risk that is smaller and I can afford. Okay, so this is like a very well-known problem that has to do when the investors are putting a lot of money in the project. Dynamic decisions. A decision, when you have a simulation, you cannot decide up front. You have to simulate. There are so many. Think of a project that is going to be around for, I don't know, 40 years. And the project has expenditures of billions of dollars. So it's impossible to make decisions up front because you don't know what is going to happen. You don't know how the world and your company is going to learn. So things will change because you know more. By the way, learning curves is another theory that we apply in the system. It's not in the slides because I forgot of that. It's impossible to remember everything. So the decisions have to be embedded in the simulation, in the way that the simulation is not an automatic thing that you push a button and at the end you get the result. But you feed the system with rules and reasonings that an engineer or a group of engineers would take given those conditions. So the decisions are embedded in the simulation. This is very interesting, very powerful. Authoring, not everything is inside the Smalltalk development environment. You also have to think about the context-sensitive help, because you have to let your users learn the domain from your system. So this is not a system where you know everything about the domain and you go to the system to tell the system what to do. It's a system that will help you understand what to do. So help is very important, so we spend a lot of effort and time in the content of the help, so it's not a boring manual. So we have technical writers. We write a lot of specification documents. Actually, we have a full library describing all major abstractions. Here, this is important because we have this conflict. We are programmers, so if we write documentation, the documentation won't match with the source code because the source code changes faster than the documentation. So the documentation is useless and dangerous. So we decide in the early stages of this project, we decided not to document the source code, but to document the abstractions that the source code was trying to reproduce. So today we have a library of documents with those abstractions. Well, here is, I have a problem with the internet connection, so there was a video about the documentation that I cannot show right now. Well, we have how-to videos. We prepare videos and movies to let our users understand better the domain and the system. And on the way, we had to prepare a lot of training material, courses, workshops, educational material, examples, best practices. Why is I mentioning all of this? If this is not software development, because this is the consequence of a very virtuous cycling of software development, where the system is so powerful and complete and interesting that requires a lot of support, of educational support for the people working in the company and the end users to make sense of all those data and information and knowledge. So we also have blogs, of course. We have two, actually. One is public for our users, and the other one is internal for our staff. So we have a lot of things about engineering. For instance, the system has a built-in functional modeling language that is used for end users to express dependencies. We have, of course, units and dimensional analysis, which are very important in engineering. And this is with automatic detection. And again, another complexity, additional complexity, because in the oil industry there are two unit systems. One is metric and the other one is oil fill, like cubic meters versus barrels. We have a lot of Excel interoperability because engineers use Excel a lot. We have high quality graphs. We had to work on that a lot also. So our plots and charts, everything you would expect, like anti-aliasing, transparencies, gradients, etc. There is a lot of effort in the quality control part of the system. We gave presentations about this in several conferences. So we have a lot of unit tests, 7,500, with a high coverage of 80%. We have independent testing, manual testing, functional testing, if you will. We have 30,000 tests with a professional QC team that works independently from us. Our recidivism is 0%. So bugs doesn't come again. We have an active peer reviewing methodology, so all the code we write, everything is peer reviewed. And we have, of course, daily integration, so every day all the contributions are integrated and all the entire system is rebuilt from scratch. So we have many tools for doing this. And we have a lot of metrics and estimations. And the distinction here is that for us, a complexity metric is not a number, it's a probability distribution. And we use that to estimate how long a project will take. We have a lot of things in the project management, but the two main are validators, which I presented in Smalltalk solution in ISAG in 2007. Essentially, every object in the system, and there are many objects, knows how to validate itself in the problem domain, in that context. And you have user changes. I presented this also in some conferences. And user changes are very important because every user action is recorded in a way that you can redo it. You can perform that. And this is very powerful, has a lot of interesting applications. In the chapter of interoperability, which was presented in Innovation Awards in 2009, we have Jamestown support, and the system also runs file-based. We have cloud computing, which allows the simulation of thousands of scenarios in parallel, which is very powerful for Monte Carlo. We have web services to connect our development environment with help desk, and we have several web-based tools. And of course, integrated SIP and email for fast communication with help desk. And we have some research projects like low-level Smalltalk. We had some presentations in all these conferences about that. Processes, continuations, instance behavior, and more importantly, applications of instance behavior. Another project was about telephone triage. was also presented in ISAG and Smalltalks, and so it's a tool for real-time decision analysis in healthcare institutions. A percolation project, which is a virtual laboratory to support mathematical research, and some research on homological algebra, also presented in Smalltalks 2009, where it's a Smalltalk model used to verify a scientific research project in that field of mathematics of homological algebra. Visual objects also shown in some conferences is a visual development environment with direct object iteration. So we have a lot, okay? And I will finish by showing you, my connection is not working, so I have this in another. Where it is. ¿Cómo? Perdón. Sí, sí, sí. So this is a video that shows how we work. Has some music that is not working. Don't laugh. This is Valeria. And this is the place where we work. So we pay a lot of attention to the environment, the working environment. And, well, the video didn't work as expected with the music. The music is composed by my son, by the way. He will kill me. And so that's all. I just wanted to share with you these 10 years of very hard work, but very happy 10 years. Yeah, sure. We work in Ezeiza, but the company is also located in the United States and in Europe. The development team, the documentation team, help desk, the guy that made the movie, which is now recording this, also work for us. So there are several teams. The quality control team also works in Argentina. I don't know, maybe 20-something people. Well, for people that live in Argentina, this is a very interesting example of the things we can make from Argentina to companies all over the world. By the way, the company doesn't have any client in Argentina or South America. Okay, so this is real for export.
I want to congratulate on what you have done. Leandro, critics, I like especially what you've done on the Q quality assurance and the computation. Was it difficult to persuade management to allocate resources for that? And how did you
Have we given them any chance to say no? Because when our the secret phase of the project included the testing and the documentation of that part of the project. So when we presented the new thing, we presented the full package. Okay? The interesting discovery was something that we haven't identified yet, that we thought that as unit tests were enough. It took us longer to discover that that is not enough. Even with a very high coverage like ours, that is 80%, you still need an independent team of professionals doing QC. That is very important. But they came later when the maturity of the company and the decision makers was already in place. The mic.
Sorry, you can translate my answer.
Your answer? Yes. So I will make the answer. What's your question?
Quería saber si el modelo de decision analysis es lo suficientemente abstracto o general para poder ser aplicado en el desarrollo de una aplicación.
Okay, the question is our decision analysis support or tools general enough as to be used in any other application? Well, the idea is that we have a very clear architecture where we separate very clearly which is general from which is particular, okay? And so in principle, yes, everything that we have done has the part that is general enough as to be used in other processes or other projects. But the particular part, which is very clearly separated from the general one, is also very interesting. So you would take some things to prepare the meal, the ingredients, but you won't have it cooked. So you will miss something. So as a starting point, yes, of course, because all we have are very general things that you can find in the books. It's okay? Okay, thank you.